I'm Joe SELLIKEN. I'm a board-certified pathologist, environmental activist turned into a peripatetic dilettante. I have organized board review courses in 20 different medical specialties to help over 140,000 physicians get ready for their board exams. But I've had a long-time interest in environmental problems, undergraduate environmental activist when the issues were air pollution, water pollution, and pesticides from Rachel Carson's Silent Spring. I came to first meeting here in 2019, or rather 2013. John Kirch commends us for coming to his meetings. We've got to commend him for putting in 10 times as much effort organizing these meetings, which have been excellent. From meeting in Columbus in 2013, I was inspired to go that fall to CERN for a international thorium energy conference where I wound up meeting Dr. Ganapati Myneni, born and raised in PhD in physics in India, then working at Jefferson Lab, U.S. Physics Laboratory in Virginia. We were both heading back to Dulles Airport, where I was going to run around Capitol Hill to spread some enthusiasm about thorium energy. I invited him to come along. He said he couldn't lobby, but he'd have to take a day or two off as vacation time to come around and watch me interact with members of Congress. Since then, I've accompanied him 6 years in a row to India in an ongoing quest to develop a super safe nuclear energy along the lines of, let's see, here the orange in the middle is the subcritical mass. It does not have the means of sustaining itself. It has to be pushed along by this yellow accelerator in the blue box. The blue boxes are the concrete structures around this thing. The accelerator strikes a spallation target, something which, when hit by a high energy, shakes loose a few neutrons, enough to sustain the reaction. If it gets a little hotter than we want, all we have to do is turn off the accelerator and then the reaction stops immediately. Very safe. We do not need a containment dome. The hallmark of American nuclear reactors are these usually pairs of spherical containment domes, 3 to 4 feet thick of reinforced concrete, which are 10,000 times the volume of the reactor in order to be able to sustain an explosive decompression of the reactor. Why an explosive decompression? Because we have to moderate, that is slow down, the neutrons in order for them to cause the next fission in the chain reaction. They need to be slowed down by about 90%. To do that, Admiral Rickover first thought of having molten sodium, until it was pointed out that submarines are in water, and molten sodium reacting with water is a nasty reaction. So we came up with light water reactors. Well, hot water makes a lot of pressure, and so if we were to have an explosive decompression of the reactor, it would be quite a mess. Hence, 10,000 times the volume contained in the containment dome. With our advanced subcritical mass molten salt reactor, the molten salt gets hot, it slows down the neutrons, gets hot, but it does not create high pressure. And so it has that feature, safety. Now, the other thing, we can modulate the amount of energy by putting more or less accelerator. We can run this as a baseload power and have a sharing of the energy for other purposes, industrial processes such as slacking lime. About 8% of carbon dioxide put in the atmosphere is from burning fossil fuels to heat up calcium carbonate to drive off carbon dioxide. That adds about 8-9% to the carbon dioxide burden in the atmosphere of things. Another advantage of the thorium is that we don't have the uranium-238 or 235, which create actinides, which have long half-lives, hence the problem of the storage and disposal of the nuclear waste from our light water reactors. So we obviate that problem to a large degree. The waste products from the thorium reactor may be safe after about 300 years instead of more like 3,000 years, which is an unreasonably long time to imagine that we're going to be responsible for safeguarding the nuclear waste of light water reactors. Now, let me get off on a little something. This is all very good news. Now let me suggest another piece of good news about how such things can be financed. Are any of you involved in real estate to know what a 1031 exchange would be? Okay, 1031 exchange, you sell some real estate. Ordinarily you would pay tax on the sale price less the depreciated basis. By having a 1031 exchange, you can take that money and transfer it to the purchase of like-kind property, and it is not a taxable event. This turns out to be a significant part of the economics of apartment houses, that owners of apartment houses from time to time sell them in order to restart the depreciation process at a higher level. So, suppose we were to make investment in research and development of climate-safe energy as a like-kind exchange that could be applied to a 1031 exchange. Let us also look at the question of 401k investments, in which a limited amount of money can be tax deferred. But suppose we were to qualify certain climate-safe investments as eligible to have a 401k treatment for a much larger amount of money, perhaps a portion of one's net worth, so that we don't have poor people investing in things that are beyond their capacity, but we have numbers of billionaires in the world who might well be encouraged to tax defer in a 401k that would be specified only for climate-safe energy development. Who's to decide? Perhaps applications for such things could go through people selected as qualified scientists from the National Academy of Science or something. This would be something that would have to be worked out in relation to legislation to make this happen. The other thing that could happen is to leverage these investments further with tax incentive investments. If one purchases treasury bonds, and those treasury bonds are applied, the purchase of those treasury bonds is applied to investment in climate-safe energy, the interest would be tax-free. I think that an enormous amount of money can be raised for the research and development and deployment of climate-safe energy. Now, let me mention another kind of thing altogether, and that is the risk of not getting at it and stopping the emission of carbon dioxide as soon as possible. The center of the Earth and Venus have radioactive material enough to make molten cores. Those molten cores melt their way up through complex minerals and release atmosphere. When they melt up through carbonates, it releases carbon dioxide. If it melts up through sulfates, it releases sulfur dioxide. There's not much in Venus to reabsorb that carbon dioxide. 800 million years ago, the Earth got very lucky. That got something that Venus did not. Photosynthesis. It was not initially chlorophyll. It was initially the pigment of blue-green algae. But that allowed the resequestration of the carbon which had been unsequestered from complex minerals by volcanoes, now resequestered to make the elements of life. And when plants and animals die, they make fossil fuels. No, we need to reposition coal and oil and natural gas, not as fossil fuels, which implies we should dig them up and turn them into atmospheric carbon dioxide. Instead, they should be repositioned as the blessedly resequestered carbon that should stay that way forever. Now, we're going to need to have liquid carbon fuels in order to have airplanes. There's no substitute. But a liquid carbon fuel can be made from organic material, a nice thing is that man could decide to stop digging up, affirmatively putting in action in order to dig up coal and oil and natural gas. But the warming created from that can potentially restart a Paleocene-Eocene thermal maximum. 55 million years ago, the release of methane caused an increase in ocean temperature. If you release equal quantities, equal weights of methane and carbon dioxide over 20 years, the integrated greenhouse gas effect of the methane is 72 times the greenhouse gas effect of carbon dioxide. If the little bit of warming from carbon dioxide were to initiate release of methane, that release could potentially become self-sustaining, even self-accelerating. And when this happened 55 million years ago, raised the ocean temperature by 9 degrees centigrade and Fahrenheit, rather, 9 degrees Fahrenheit, and it lasted over 100,000 years, caused the elevation of sea level by over 400 feet. We've got to act in time. Thank you very much.